Airframe symmetry refers to the balanced and aligned configuration of an aircraft's structural components. It ensures that both sides of the aircraft are mirror images of each other, promoting optimal aerodynamic performance and stability. Here are some common methods of aligning and checking symmetry in an aircraft's airframe. Design and manufacturing. The foundation of achieving airframe symmetry begins during the aircraft's design and manufacturing stages. Precise engineering, CAD, computer-aided design, systems, and manufacturing processes play a critical role in producing symmetrical components, such as wings, fuselage sections, and empennage structures. Jigs and fixtures. During the assembly process, jigs and fixtures are often employed to align and position structural components accurately. These tools provide a standardized reference point, ensuring that both sides of the aircraft are symmetrical. Jigs and fixtures are especially crucial for large structures like the wings or fuselage. Measurement and alignment tools. Various measurement and alignment tools are used to verify and maintain airframe symmetry during assembly, maintenance, and repair. These tools include laser alignment systems, coordinate measuring machines, CMMs, optical instruments, and precision measuring instruments. They help technicians compare measurements and alignments on both sides of the aircraft to identify any discrepancies and make necessary adjustments. String lines. String lines or wire alignment techniques are commonly employed to check the symmetry of large components, such as wings. By stretching strings or wires along specific reference points on both sides of the aircraft, technicians can visually compare the alignment of the structure and identify any deviations from symmetry. This method allows for adjustments to be made to achieve optimal alignment. Symmetry checks. Regular symmetry checks are performed during routine inspections and maintenance procedures. Technicians visually inspect the aircraft's external surfaces, components, and control surfaces to identify any visible asymmetries or discrepancies. This includes checking the alignment of control surfaces, landing gear, engine nacelles, and other critical elements. In addition to these methods, computerized systems and advanced technologies are increasingly being utilized to assess airframe symmetry. These systems employ 3D scanning, computer vision, and advanced algorithms to analyze the geometry and alignment of the aircraft's components, ensuring precise symmetry. Achieving and maintaining airframe symmetry is essential for the overall performance, safety, and efficiency of an aircraft. Adherence to proper alignment and symmetry checks helps maintain stability, reduces drag, and ensures consistent handling characteristics, contributing to a reliable and well-balanced aircraft.